Okay, so we've been talking about how the removal of vegetation at Earth's surface can destabilize our soils, right? We lose the anchors or the roots that keep soils in place. We lose the ability of leaves to dissipate the force of raindrops and reduce the impact of splash erosion. And of course, the loss of vegetation means there is nothing there to mop up that extra precipitation. And as a result, runoff ensues. So, what are the consequences of this? First and foremost, there is a strong connection between erosion from the land and reduced water quality. So, typically, our bodies of water sit at lower elevations, and anything that runs off the land finds their way into creeks, rivers, streams, lakes, and ponds, and ultimately the ocean. This is a process we know as sedimentation. So as that sediment gets into the water and into the water column, the sediment itself makes the water quite murky. This murkiness is measured by turbidity. It's a measurement of how well light passes through water. The more turbid the water, the more murky it is. And when it's more murky, it means less sunlight penetrates. And if less sunlight is penetrating, that's going to reduce the amount of photosynthesis and ultimately reduce dissolved oxygen levels. This will have a huge effect on aquatic life. Furthermore, fish that are highly sensitive to these changes oftentimes get their gills clogged with this sediment. Many fish actually spawn and lay their eggs in the gravel on the stream bed. Well, these spawning sites and gravel beds become blanketed by the sediment that settles out to the bottom of the creek or river, and that reduces their reproductive viability. Darker sediment in the water as well heats the water up, right? Dark colors absorb more insulation from the sun. So warmer water also means less dissolved oxygen in the water. Warm water doesn't have the same capacity to hold dissolved gases, and that affects aquatic life. Furthermore, more sediment in the waterway actually shallows the waterway. In other words, it can't hold as much water, so flooding will be intensified. We're definitely not strangers to this. The Genesee River, which of course runs right through Ra-Cha-Cha, has a lot of sedimentation. It is highly turbid because in the southern parts of the river, we have a lot of unsustainable agriculture, overcultivation, lots of runoff. The river, of course, cuts through Rochester, which is an urban hardscape where there's a lot of runoff coming from our streets, and therefore we have a lot of sedimentation, and we can actually see the plume of sediment as the Genesee flows into Lake Ontario and discharges sediment into the lake. We can see this from space. Here's the plume of sediment moving to the east as our prevailing winds push it in that direction. We've seen this image before. This is the Betsy Boca estuary, located in the most heavily eroded country of the world, Madagascar. Severe poverty has led to severe deforestation and unsustainable agriculture. The wholesale removal of vegetation has accelerated erosion and reduced water quality. Not only do we get increased sedimentation, but it also reduces the soil's ability to allow for infiltration, right? We get compacted soils. So instead of running or infiltrating into the soil, it runs off the surface. That means we have a hard time, or the soils have a hard time recharging their groundwater supplies, what we call aquifers. And there's lots of regions in the world that depend upon groundwater for drinking and for irrigation. Well, if more of that water is running off the surface, that means you're going to have less storage and capacity and supply of fresh water. The final major ecological impact of soil erosion is what we call desertification. This is a process. It's a human-induced process where erosion has progressed to a point where the ecology and production classify a once fertile area as desert. In other words, the productivity of the soil has dropped by at least 10%. Anywhere from 10 to 25%, we consider it moderate desertification. 25 to 50%, we refer to it as severe desertification, and 50 plus is very severe. So here we can see a grassland area that has been mismanaged, perhaps overgrazing or overcultivation. It doesn't always look this extreme. It doesn't always look like a desert, although this is the most extreme example. In fact, desertification often does occur, both naturally and human-induced, along the fringes of deserts, where human activity is removing vegetation and causing the dispersal of the desert moving into vegetated areas. That's the consequences of soil erosion, and next we're going to offer up solutions.